This video will walk you through the steps on how to find the solutions to equations using inverse matrices, and will also teach you how to find the solutions to a system of equations when using inverse matrices. So we're going to look at this here in a couple different formats. We're going to look at a more general example like you see here on the screen, and then we'll look at a system of equations here in just a little bit. So these equations are in the format ax equals b. Now x isn't necessarily singular x like you think of as a regular variable. X is going to be represented by the matrix of elements x and y. So the solution to your problem is going to have these two variables represented. X is just used as a broader variable to give us something to plug in, so we have a format. But what basically is going to be happening is this. We have two matrices here. The goal is to get this big X by itself. Now, typically in the regular math, you would just divide away the A, and we get the X by itself, and we figure out how to do stuff from there. We can't technically just divide by matrix A and call it a day. The way that we technically divide using matrices is we need to take the inverse of the matrix. So our goal is to turn this equation, we want to get this matrix, this X matrix that we don't know by itself, we're going to take the A and move it to the other side by taking an inverse. The way that it's going to look is that the big matrix X is going to equal the inverse of matrix A times whatever matrix B is. That's what we're going to turn all these equations and systems of equations into so that we can solve them. So this is going to rely on a couple of skills. It's going to require you to be able to take the inverse of a matrix like you saw in the previous lesson, and it's also going to require you to be able to multiply matrices together, which you learned earlier in learning about all this stuff with matrices. So what we're going to take a look at here is how to rewrite these, then actually figure out the math that we need to do. So taking a look here at this first example, you can see we've got a matrix times this big X equals another matrix. We are going to assume that the matrices, are A and B left to right. So in order to get the A matrix to the other side, we have to find the inverse of it. So we are going to look and find the inverse of the matrix in front of the X using what we talked about in the previous lesson. So I'm going to go ahead and find the inverse of it. Now, once again, you can do this by hand, or you can choose to do it on your calculator. So what I'm going to do here to expedite the process a little bit, since I showed you in the previous video how to do it by hand, is I'm going to go ahead and just do it right on my calculator. So we have a 2 by 2 matrix. We're going to go ahead and enter that in. So you can see my button presses here. So here's my matrix, 2, -7, -1, 4. Quit out of it. We're going to pull it back up in our main screen. Hit that inverse button, X to the negative first. That'll give us our inverse matrix. So the inverse of matrix A is 4, 7, 1, 2. As you can see right there. So we need that inverse matrix in order to figure out how to get X by itself, because once we find this, that's going to move over to the other side. So I'm going to go ahead and rewrite my problem so that, again, it is an X equals the inverse of A times B order. So X is still X. We just found the inverse matrix, so we're going to plug that in for the inverse spot. Now we're going to go ahead and plug in the B matrix, which is this matrix after the equal sign. So again, we're just copying and pasting. Now once again, you have two options to do this. You can either do this by hand, as you have learned, or you can go ahead and put this into your calculator, which again will probably expedite the process a little bit here, but you can always do it by hand, use the calculator to check. But ultimately, you need to at least show these amount of steps so that I can see where you are getting your numbers from. Now, to expedite this, since you've gone over how to multiply matrices once again, I'm just going to go ahead and use my calculator. So I already have this matrix taken care of. So what I'm going to go ahead and do is I'm going to open up and put in a second matrix, so in the B slot. I'm going to go ahead and make sure it's a 2 by 2, change my dimensions there, and I'm going to go ahead and plug in my four elements. So everything's nice and plugged in, good to go. So what I'm going to do is I'm essentially doing this problem right here. So I'm going to go ahead from the names menu, A matrix with my inverse button, go back in the matrix menu and scroll down to the B matrix, put it right after it, and it'll do the math for me, giving me my final system, my final solution of 0, -2, and what looks to be 3 and -1. And that is how you solve using inverse matrices, how you solve that equation. So again, I'm looking to rewrite it so that the A matrix ends up on the other side, because we need to get x by itself, just like a regular equation. However, in order to get the A to the other side, we must take the inverse of it, hence the setup that you see here. So, if I wanted to just solve just a regular old matrix equation, that's exactly how we do it. How you will probably mess with it a little bit more is with the example at the bottom here in dealing with systems. So, the way that we're going to figure this out, it pretty much is going to be the same idea as what we did at the top. The only difference is we have a couple less numbers, which may or may not make this easier, depends on your perspective. We are going to have two matrices. We are going to get matrix A from all the coefficients right here. So it's kind of like when we learned about determinants. We're going to rip off the coefficients of all the values that are here and create our first matrix. So we'll have 2 and -3 in the top row, 1 and 4 in the bottom row. That is going to be our A matrix. Big old X, this is where we're going to get our solutions, and we'll talk about what that's going to look like here in just a second. My B matrix is simply the constants that are after the equal sign, just the 19 and the -7. Once we have this written out and set up, and again, that'll be my B matrix, all we're going to do from here is simply figure out how do we get x by itself. Well, once again, to do that, we got to get the inverse of matrix A and get it to the other side. So, same steps as the last problem. Okay, all we're going to do is go to our calculator here again, just to kind of save some time. We're going to use our calculator. So I'm going to go back into my matrix menu. Again, I'm using matrix A here just to kind of keep the letters aligned. So punch in our matrix. A couple wrong button presses there, no big deal. Back to the main screen. So hit matrix. Hit our inverse button. And you notice, it gets us a bunch of decimals, and you might be thinking, oh, that doesn't look so good. No big deal. You can write out the decimals, however, I would highly suggest you turn them to fractions. Okay? To do that, you have a couple different sets of buttons you can hit, but I would just hit Math, Enter, Enter. That looks a lot cleaner. Now, you might be thinking this is going to be a messy set of answers. Work through the problem here, and you'll see how this is going to work out. So you see our matrix there. I'm going to move this just so I can copy it nicer. We have 4 elevenths and 3 elevenths in the top row, -1 eleventh, and 2 elevenths in the bottom row. All right, so now we are going to use this so that way I can move the matrix to the other side. Because once again, in order to get that X matrix by itself, we have to take the inverse of the A. That's what allows us to move it over. So now again, it's just a copy and paste game. So the inverse matrix, which was 4 elevenths, 3 elevenths, -1 eleventh, and 2 elevenths. Your B matrix was just 19 and -7. Now, you are able to multiply this together by hand. You have a 2 by 2 and a 2 by 1. Your dimensions would line up and allow you to figure this out, to figure out your missing values. However, once again, you've done that by hand. Use your calculator to your advantage. So, once again, I'm going to go into the calculator. So I'll put this back up on the screen here. So I'm going to go ahead and matrix A, that was what we just figured out here, so I'm going to leave that alone. Let's edit matrix B. Once again, this is a 2 by 1 matrix, as there are 2 rows across, 1 column up and down, and we're going to go ahead and enter in our values. Quit out, and now we're going to go ahead and enter this equation. So we need the inverse of A, so A with our inverse button, second matrix, B. Comes out much cleaner than when it looked in the first place. So we get a final matrix, 5 in the top, -3 in the bottom. Now, what this means is it's not just 2 random numbers. The goal was to solve the system. Those 2 values, as it might also relate to what's at the top here, correspond with the variables x and y within our system. So that 5 and that -3, I can plug back into the x and y in this problem, and that is the solution that's going to work out. So my final solution, I'm actually going to write as an ordered pair. That's 5, -3. They mean the same thing, but that's how it connects back to that system. So, in order to get, once again, to figure out the solution to a system using inverse matrices, your main goal is to set up two matrices, an A and a B. Especially in the case of the system here, your A matrix comes from all these coefficients. The B matrix comes from the numbers after the equal sign, your constants. You got to take the inverse of the A matrix to get it to the other side, and then you'll multiply that inverse with the B matrix. Again, you can do it by hand. You can use your calculator. You still see there was some work that I showed out. At the very least, if you're doing it by a calculator, this is the work that I should see so that I can see where, again, you're getting all your numbers from. That, in summation, is how you find the solution to either a regular equation or a system of equations using inverse matrices.